All right, let's move forward. XPath. So these are the set of topics we are going to cover. So XPath, what is an XPath? XPath is expression language, meaning XML language, for referencing particular parts of XML document. Okay, so you can use XPath with any XML document, okay, including XML schema, of course. So examples that can be expressed with XPath. So if you want to reference the first person element in an XML document, or if you want to reference seventh child element of the third person element, or if you want to make a reference to ID attribute of the first person element whose content is the string JPassion class, or all XML style sheet processing instructions. So basically, you use XPath for referencing any parts of your XML document. Okay, so these are just a very simple examples where XPath could be used for referencing. Okay, so XPath expression criteria. So you can actually use position, relative position, type, content, numbers, strings, booleans, and functions. So we are going to cover most of this. Now, the places, example places where you are going to use XPath could be XSLT style sheet. So that's something that we are going to cover as the next topic after this. So inside XSLT style sheet, you are going to use what is called a match and select to make a references to your XML document. You use XPath when you're defining X pointer as well to identify particular point in or part of XML document that an X link links to. Okay, so these are two examples where XPath is used. All right, so we are going to do exercise 1 and 7. Exercise 1 is we are going to actually use XPath checker plugin to Firefox. I could not actually, I didn't actually time to find the compatible plugin for Chrome. So in this case, I have to ask you guys to use Firefox to install this XPath checker. And exercise 7 is display XPath of a selected element. So let's take a look at lab documentation. So exercise 1 is install XPath checker plug into your Firefox browser. So if you have not installed Firefox, I have to ask you guys to install Firefox first and then install this plugin. Okay. And exercise 7 is display XPath notation of a selected item in an HTML page. So let's actually go to exercise 1. You can actually go to, you can just search for, you can just go to Firefox, and you can go to tools and tools add-ons, and you can search for XPath checker. You can just type XPath like this, and then in my case, I have already installed XPath. What is XPath? Let's try. If you search XPath, yeah, here you go, XPath checker. Okay, and once you install it, in my case I have installed it, okay, then you should be able to use the rest of the exercises. So that's exercise 1, just installing that plugin. And exercise 7 is you can find out, you can go to any website, you can go to, for example, like a Google or Yahoo.com or JPassion.com. You can select any element and you can actually see once you install the XPath, the checker, then you are going to see view XPath, okay, and then you can actually see XPath notation of it, okay. So you can just select anything. In this case, I'm going to just choose this guy, okay? And then I'm going to see view XPath. And this is the notation of this particular, the element, okay? So that's the exercise I'm going to ask you to do. I'm going to give you guys about, why don't I actually move forward, okay? So that I am going to actually finish up some presentation, and hopefully you guys can actually do these exercises, during lunchtime, if you have to, okay? So I'm going to actually present until 12:30, okay? All right, next topic is node type, okay? So XML document is made of a tree of nodes, and there are 7 kinds of nodes: the root node, and element nodes, text nodes, attribute nodes, and comment nodes, and processing instruction nodes, and namespace nodes. So root node is not the same as root element, okay? So root node basically covers everything, including root element, processing instructions, and comment, okay? Root element is the first element inside your XML document, but the root node is reflecting the complete XML document, okay? Root element is the first root element inside the XML document, okay? So it contains entire document, including root element, processing instruction, and comment. Okay, expression result data types. So when you're using XPath expression, it gets evaluated into one of these 4 types: node set, boolean, number, and string. And the most important type we are going to deal with is a node set. Okay, so as you probably have guessed, node set is a set of nodes. Okay, so we are going to learn what a node set is all about. So node set is a collection of 0 or more nodes from an XML document. Okay, so after your XPath expression is evaluated, it will return one of those 4 types, and one of those 4 types, the most popular type is return type is a node set, and it's a collection of 0 or more nodes. Okay, and it's returned from location path expression. So what it means is the XPath expression is sometimes called the location path expression. Okay, now this node set, there are certain things that cannot be in the node set. For example, C data sections, entity references, and document type declarations. These things are actually resolved. Okay, because XPath operates on an XML document after these items are resolved. Okay, so by the time the XPath evaluation expression is evaluated, there are no C data and entity references and like this. Okay. Alright, we are going to play around with XPath expression using an example XML file, and this is XML file called the people.xml. Okay, and we are going to use this people.xml document instance to exercise XPath expressions. It's pretty straightforward. So you can see this is XML, and it has a style sheet and is a doc type. And then what's important is this people element. So people is a root element. The whole thing is root node, and root element is people. And people have 2 person element, the first person and second person. And person element has few attributes: born, died, and ID. And then it has name, child attribute, name, child element. And then it has 3 profession in this case, child element, and it has a home page element. And the name child element has its own child element called the first name and last name. Okay, and then we have a second person whose name is Richard, and in this case the name has 3 child elements: first name, middle initial, and last name. And this one has a single profession, and it has a hobby. Okay, so this is the example XML document instance called people.xml. We are going to play against we are going to play XPath expression against this particular target XML document instance file. Okay, so let's move on to the concept of location path. Okay, So a node set is returned by location path expression. So when we say XPath expression, we are typically talking about location path expression. Okay, location path is made of location steps. Okay, so we are going to see example of this one in the following slide. Okay, location step contains an axis and node test separated by double colon. So it could have an axis and node test, but in general, this axis is omitted. So we're not going to actually deal with this particular axis example at all. Okay. So location step could be specified in abbreviated form. So this is basically what we are going to deal with. We are not going to actually deal with the axis. Or it could be unabbreviated form. So in this case, axis is specified. Okay. Again, we are going to mostly focus on the abbreviated form where we don't specify axis. Alright, so location path can include root, element, attribute, comment, text processing instruction, and wildcard, multiple matches with this vertical, and compound location path. So we're going to actually look into each of these in a bit more detail. Okay, so root location path selects the document root node. So that is basically slash. Okay. And it's represented by slash. Again, this is actually root node, not root element. Okay. Now, absolute location regardless of where the context node is. So we're going to actually learn the concept of context node in a few minutes. All right. So here, this is the case. We are referencing in fact, in this case, is a root element. Okay. So slash. Just a slash is root node, and slash people in this case is referencing root element. Okay, so basically what it does is reflecting. I want to get all people elements, all immediate people element from the root. Okay, so in this case we have only one, right? Okay, so the as we move on, I'm gonna, so why don't you actually, I'm gonna show you how to use this XPath checker in the hands-on lab. That's basically exercise 1. So what we are going to do is, from the Firefox, we are going to open the file. So here, from your Firefox, open the file. So people.xml file is provided under the hands-on lab. So you go to hands-on lab. In this case is the WSXML XPath and the samples. So underneath you see people. Okay, XML file, and open it. So this is the XML target XML document instance we are going to play around. Okay, so right now you open it. Okay. We just did it, okay, and then we are going to view XPath. So here the 2.1 is basically what we just did. So here, right-click it and view XPath. Okay, all right, and then you can specify anything you want. So in this case, we are going to say people. Okay, now once you press return, it will select. It says one match found. So basically, it return this people element, people node. Okay, so that's basically what I just did. Okay, and that's the result I'm capturing right here. Okay, so what it means is that get all immediate child people nodes under the root. Okay, because we have only one people, it will just display one match. Okay. The child element location step. So expression is a child element name, and it basically selects all child elements with a specified name of the context node. In this case, the context node is the root. Okay. Now the concept of context node is in XSLT. Again, we are going to actually take a look at the concept of actually context node in XSLT later on. So don't worry about it. I mean, basically, there is a concept of this context node. Okay, now in this case we are going to get second profession of person element on the people. So what it means is that I want XPath to evaluate this expression, and what it means, find all people element. There is only one people element, right? And on the people element, that is a context node. Find all person element, okay? And then among the all person element, try to find the second profession. Okay? So in this case, it's going to return. So again, we are going to try people, person, and then profession 2, like this. So if you say profession, then it will return 4 because there are 4 cases, right? But I want to just have only the second one. Okay, so in this case, it will just return 1 because only the first person has the second profession. The second person has only a single profession. Okay, all right. And next one is attribute location steps. So you can specify attribute using attribute name. Okay. So in this case, and other location steps. So if you want to actually make a reference to attribute, then you're going to use the @ sign. If you want to, now these are examples of other location steps. So text node, if you want to get the text, then you are going to use a text parenthesis. So what it means is that select all immediate text nodes of a context node. This one get all processing instruction. This one get all comment nodes. This one, when you say // that means all XYZ node under the root. So it doesn't have to be immediate. So if you have a single / that means immediate child nodes only. But if you have a // that means all child node under that. Okay. So in this case, if you say first name, then we are going to have all first name cases, right? Okay. And now if you want to get the text, so this is the case that it returns a first name element. Now you want to get just text. So here you are going to say text like this. And then it will just return only the text. Okay. This is a comment. So replace each. So this is an example. So this is XSLT. So don't worry about this dissect that much. But what you want to do, sometimes is that I want to search for all comments, and then I want to replace that comment with this, like comment deleted, right? So this is XSLT notation. Where you want to find all. So this is the XPath notation, XPath expression. Find all comment, okay, and then replace with this. That's what it meant. Okay. All right. So right now is 11:30. So I am going to ask you guys to try this exercises 1 and 7, and also if you want to do exercise 1, which is basically doing up to this point. Okay. That should be good. So I'm going to give you guys 10 minutes to this exercise, and we'll have 30 minutes lunch time. So we will be back in 40 minutes, which is the 10 minutes after 1. Okay. Next topic is wildcards. So you can use wildcards when you specify your XPath expression. So just like the concept of wildcards in other programming languages, it matches different elements and node types at the same time. So there are 3 different kinds of wildcards you can use. One is node, and the other one is a star, and the third one is @star. Okay, so let's take a look at each of these in a bit more detail. So node is node function matches all nodes including everything. So element, text, attribute, processing instruction, namespace, comment, everything. Okay. The star, however, matches only element node regardless of the type. So it doesn't match attributes, it doesn't match text nodes, it doesn't match comments, it doesn't match processing instructions. And the @star matches all attribute nodes. Okay, so you can see node is on the top, is the broadest. It covers everything. Star just covers element, and at star covers just attribute nodes. So in this case, when you use this one, so here we are going to we want to get all the elements. Okay, so in this case it will just collect all the elements: people, name, profession, first name, and everything. So we have how many? We have 15. Okay, however, if you use node, then it should be just one match found. That's interesting. I expected a lot more. So let's see. Oh, I see. So I should actually say this, like this. Then it includes even the blank spaces. Okay, so it does have. It returns 44 the node in the node set. Okay. And here I want to collect all the attribute star, and there are 4 matches. And multiple matches. Just go. Okay, so you can use OR operation. So example, so profession or hobby, or first name, last name, profession or hobby, or this one ID attribute and X link and type attribute, and this is all elements and all attributes. Okay, so in this case, I want to have all professions and all hobbies. Okay, so here let's try this. Profession and star and all hobby. Oh, why return just one? Oh, I have misspelled S here. Okay. Alright, so now it returns 5. So 4 profession and 1 hobby. Okay. Now compound location paths. So compound location path, basically combination of multiple location step with a /. As a default, is going down the hierarchy from the match node to other nodes. Okay, so this is actually default axis downward. Okay, dot refers to current node. You can use the dot refers to parent node, just like in file system, and // refers to descendants of context node. Okay, so all descendant, not just immediate descendant. So here we want to get the all peoples, all persons, all names, and all first name. Okay, so here let's try this. We get all people. There is only one, right? And then we get all person. Here we have 2 person elements returned, and then we want to get all name. Okay, then we have a 2. And then we say first name. Okay, then we have 2 cases, and that is first name case. Oh, now if I want to get the text nodes of these first names, then as expected, this is what we have seen before as well. We are getting just ln and Richard. Okay. Okay, so here we are using this dot dot notation. Okay, and this dot dot notation is used to refer parent. Okay, so let's try middle initial. There is only one case, right? And then we go dot dot goes to the name element, and then we get first name. Okay, now we get the first name. Okay. First name and current node. So this is, so we say first name. Okay, this is the same thing as this because this is a current node. Okay, so you know this is the same thing as this, same result. Okay, so exercise 2, perform various XPath operation. So I'm going to give you guys 7 minutes to finish exercise 2. Okay, so some of you guys already have done this one. Next concept we are going to learn is predicate. So predicates are used to select a subset from a node set. Okay, and it can be applied in each of the location step in the location path. Okay, and Boolean expression applied to each node in the node set. So let's see examples of predicates. So in this case, it's a value comparison. So we like to actually find all profession whose value is physicist. Okay, so period stands for string value of the current node. So it's like SSL value of. Okay, and you can use single quote and double quote. Either one is fine. So here, let's try to find and profession and string value equal and physicist. This, and we should did it work? Okay, so I'm not sure it worked or not. Yeah, so here we go. So we should have one profession and physicist. Yeah, that looks good to me. Press enter. Didn't work. Oh, looks like almost like this is actually crashed. Okay, so let me just start it again. Okay, I have to open the file. Open the file and XPath samples people, and then view XPath. Okay, alright, so that is good. So let's try profession dot equal physicist. Oh, no. Oh, okay, misspelled, I guess. F-H-Y-S-I-cist. Huh. Let me see. Let's copy this guy. And profession, I think I spelled correctly. Oh, I have to actually have a double here. Okay, so it returns. Okay. Alright, so that worked. Now, this is an example where the find person element that have a profession child element with a value of physicist. Okay, so in this case, and this is the case, find the person element whose ID attribute is P4567. Okay, so instead of dot, we are using child element of person, and this is the ID attribute. Okay, so that should actually return person, yeah, so it should actually return person element. In this case, profession is physicist. Okay, so I'm gonna actually let you do this exercise later on yourself. And we can use relational operators. So all relational operators that we can use like this. And here we like to find all person elements whose born attribute numeric value is less than or equal to 1915. Okay, so it should return one person. Okay, you can use and or inside the predicate. Okay, so here I like to find all person elements whose born attributes values are between 1915 and 1920 inclusive, and this is or case, whether first name is Dick or first name is Sang. Okay, so it should return one match. And you can also have non-Boolean expressions. So predicates could be non-Boolean expressions, and they will be converted into Boolean. Okay, so if you're using number, it will actually it will return true if it is not 0. Okay, for node set, it will return true if node set is non-empty. For the case of string type, it will return true if non-empty string. If it is a non-empty string. Okay, so let's see an example of this. So in this case, the name, middle initial. So the name elements which have middle initial child element. Okay. So in this case, should return just one match. So what happens is that middle initial is a node set, right? So it will return, wait a minute. Yeah, okay. So this is the predicate when it's actually being used. In this case, as a node set, middle initial node set, there is only one, right? Okay. So it will actually return name element that contains middle initial. And can be applied to each step in a location path, as we have seen before. So in this case, we have predicates for this location path as well as this location path. So we are looking, so select all people child elements. Okay, we have only one people element, and then select all person element whose born attribute has a value numerically less than 1950, and then select all name attribute, name elements which have a first name child element whose value is ln. Okay. Yeah, I think in previous case, I'm not sure I actually explained correctly. So this case is when middle initial is present, that is actually predicate evaluation. Okay, so middle initial is present or not. So in this case, the only name that has a middle initial is present is the first person. Okay, yeah, hopefully that's the way I explained it. Okay, so that is this. It should return this result. And exercise 3. So I'm gonna let you guys to do this exercise maybe 7 minutes. Okay, non-node set expressions. So there are 4 different type of returns: node set and number, string, and booleans, right? Okay, so these are numbers, and these are strings, and these are booleans. Okay, and they cannot be used in match pattern of XSL template. Again, we are going to talk about this is XSLT stuff, so don't worry about this statement. I should actually remove all XSLT reference in this presentation because that causes more confusion rather than helping. Okay, so basically just focus on numbers and strings and booleans. Okay. And for numbers, you can certainly do arithmetic operations. Okay, so again, this is an example of XSLT. Okay, so in this case, XSLT is using a select attribute. This is the expression, numeric number expression. So if you do, here 6 plus 7, something like that, then it will return values like this. Okay, and string values is JPassion, then you should return JPassion. Nothing fancy. And for Boolean, if I say true, it will return true. Okay, and if I say 1 is less than 2, it should return true. If I say 2 is less than 1, then it should return false. Okay. Okay. Strings. Strings is ordered sequence of Unicode characters, and it works with equal and not equal comparison operators. Okay. Now functions. So functions return a value of one of these 4 types, as we talked about: node, set, boolean, number, and string. Okay. So these are the set of node, set functions, like a position. Okay, so again, this is XSLT, the expression. So what's important is this is XPath notation, position. Okay, so position, current node's position in the node set, and the count is number of nodes in the node set argument. Okay, so if let's see an example of this. So if I say count, and I want to find all person, like this, and it should return 2. Okay, if I say name, it should return 2. It should return 2. So if I say profession, then it should return 4, right? And if I say hobby, then it should return 1. Okay, as expected. String functions. String functions convert any type of argument to a string. So, booleans will actually return true or false, and what gets displayed is the string values, right? Node set. Yeah, this is actually important. Node set. When you say string, when you're using string function against the node set, it will return string value of the first node in the node set. Okay, so let's see if we have any example of that. Looks like, yeah, here we go. So yeah, we are going to try this one later on, but we'll try this. Okay, so let's say profession. If I say profession, there are 4, right? Okay, now if I say string version of this, then it will return the string value of the first node in the set. Okay, so profession, just profession slash profession has 4 in the node set, right? But when you're trying to get the string value of it, then it will take the first one of it, and then will display the first node, the string value of the first node. So same thing with, let's say, name. So let's try name. Okay, so if you say name without the string, there is a 2 in the node set, right? Okay. Now, if you want to get the string value of it, by the way, string value of it is the text value of all the subsequent nodes. So that's the reason it will display ln and Turing. Okay. So if I say string, like this, okay, ln Turing, all right? So the same thing with the first name. So if I say first name like this, it will take the first node in the resulting node set, and then it will take a string value of the first node in that node set, okay, which is ln. Starts with argument 1 and argument 2, returns true if the first argument starts with the second argument. Okay, so in this example, let's say start with Richard, and Rick returns true, okay, because Rick starts with this. And this one returns false because this Richard doesn't start with R-I-C-K. Okay, so let's try starts with and Sang, and so I'll say S-A, and it returns true. If I say AX like this, then it should return false. Alright. It returns true if the first argument contains the second argument. Okay. And the substring basically returns a substring of argument 1 whose length is the length starting from the position. So in this example, the length argument is, by the way, is optional. So in this case, you have argument 1. Oh yeah, so this is the case you have argument 1 and position and 2 length. Okay, it returns m. So starting from here, and then it will return 2 to return mm. In this case, it will start from 2 and then all the way to the end. So without the length, it will actually go to the end. So it will return this much from the second. Okay. Substring before returns the substring of the first argument string that precedes the second argument's initial appearances. Okay. So basically, if I say I want to actually get the string before the first instance of this guy, slash, so it will return mm. Okay. If I say the D, then it will display mm slash, right? Okay. Substring after is actually reverse of it. String length, you can display the string length. Okay. Returns the length of the string value of the argument. White spaces characters are included and markup characters are not counted. So in this case, argument 1 is optional, returns the length of the context node. Okay. So in this case, we want to get the position, the first one of the first name, and then get the string. Okay. And here, string length is going to display 4 because this ln is 4 characters. This is what we just talked about. Okay, so I'm going to let you guys try this. And normalize spaces. Basically, normalize white space. It will remove all the white spaces, basically. Okay. Yeah. So in this case, when we do, we are going to. Oh, I should actually say the. String. Let me see. Okay. Normalize space. Yeah, looks like I should this one is not correct, looks like. Okay, so I'm going to say, let's actually try string slash name, and we're gonna use a position function. Okay, so it will return ln string, and then I'm gonna say normalize space like this. Then it will normalize all the spaces, and then for space it will have just a single space. Okay, so it looks like I need to change slide number 73. 73. I have to fix that. Okay. Alright, so that is normalized space. And Boolean functions, again, true, false, and Boolean. Okay, so here it converts argument 1 to Boolean and returns result. If no argument, use the context node. If argument is a node set, true if it contains at least one node set. At least one node in that node set. Okay. So if I say name, then it has the 2 in the node set, right? So if I say Boolean, then it should return true. Okay. Now if I say name X, then it should return false because there is no node in the result set. There is no element that has name with the name X, right? Okay. Number functions. So converts arg1 to number. If no arg exists, use a context node. This is a sum. Take a node set as an argument, converts each node in the set to a string value, then converts each of those strings to a number, and finally it adds the numbers and returns the result. Okay, so basically sum. So here, typically you're going to use sum for the numeric value. Okay, so here I like to actually sum all the born attribute values. Okay, so it's going to, we have 2 values, right, from 2 people. So it's going to be 38, 30. Exercise 5 and 6. So I'm going to finish up the presentation. So what we covered in this presentation is XPath expression data types and the concept of node types, node set, location path, along with the location steps, and wildcards and predicates and functions. Okay. All right. So I'm gonna actually ask you guys to do exercise 5 and 6. I'll give you just 6 minutes to finish this. Okay, and then we're gonna move on to XSLT. Okay.